About fiber optic cables whenever people talk about the telephone system, the cable TV system, or the internet. Fiber optic lines are strands of optically pure glass as thin as a human hair that carry digital information over long distances. We will show you how these tiny strands of glass transmit light and the fascinating way that these strands are made. Fiber optics. Fiber optics, optical fibers are long, thin strands of pure glass about the diameter of a human hair. They are arranged in bundles called optical cables and used to transmit light signals over long distances. If you look closely at a single optical fiber, you will see that it has the following parts. Core, a thin glass anther of the fiber where the light travels. Cladding, the outer optical material surrounding the core that reflects the light back into the core. Buffer coating, plastic coating that protects the fiber from damage and moisture.
Next video, we will show you how an optical fiber works. The material used is a transparent bottle modified with a hole in front, a laser pointed in the hole, and water with propylene glycol inside of it. The light of the laser bent and followed the movement of the liquid all the way to the catch basin. It does this, it is because of total internal reflection. As the light enters the stream, it is reflected as soon as it hits the liquid. The light are reflected because of the difference of their index of refraction of the propylene glycol and the air. Great amount of light were reflected and reached the end point, but some lights were refracted outside the liquid. In an optical fiber, the light travels through the core by constantly reflecting from the cladding, because the angle of the light is always greater than the critical angle. Light reflects from the cladding no matter what angle the fiber itself gets bent at, even if it's a full circle. Because cladding does not absorb any light from the core, the light wave can travel great distances. However, some of the light signal degrades within the fiber, mostly due to impurities on the glass. The extent that the signal degrades depends upon the purity of the glass and the wavelength of the transmitted light. In summary, for total internal reflection, when light passes from a medium with one index of refraction to another medium with a lower index of refraction, it bends or refracts away from an imaginary line perpendicular to the surface. As the angle of the beam through index of refraction becomes greater with respect to the normal line, the refracted light through lower index of refraction bends further away from the line.
Internet is the fastest growing technology on the earth today, and this is mainly possible because of fiber optics, the hair-thin glass wires that carry laser light communication signals around the globe. Fiber optics is important technology. Mankind's future depends upon the effectiveness of these communications. Well, for one thing, we are still having silly delays on the internet all the time, even with high-speed connections, and even when accessing perfectly normal web pages. Secondly, we don't have video on demand over the internet yet. And thirdly, there are all kinds of futures applications like telepresence, holographic transmission, and true virtual reality, none of which are even remotely approachable by the fastest technologies we have around today. What I think personally is that it probably will continue like it has in recent years. Imagine if all computers are connected in the internet with the optical fiber, the connection would be considered as a speed of light, no delay, and no waste of time.
Beat this mob.